because today's lesson is kind of short. But we do have a lesson plan due next week, right? And then I will go over the lesson plan with you. All right. What is the lesson plan you want to do? And so I will go over the lesson plan with you. And then the other thing is our final exam. Final exam is May 6th. Same time, okay? Is a 7, well, according to the schedule, it's 7:15 to 9:15, right? So it's a Monday, May 6th, 7:15 to 9:15. So we take a final exam. So the content area will be the things we cover from lesson 1 to lesson 7, okay? Pretty much like a homework, you know, your problem set homework, okay? All right. And that's can go over tentative schedule. And next I want to go over with you for your lesson plan. Okay, where is the lesson plan? I'll go to the front here. Now, if you click the lesson plan, I upload the example for lesson plan. And then actually your lesson plan, you will do part 1, just like your teacher education program for EDUC program. And then class, you know, and then I'm gonna change this. You do part 1 and part 2, okay? Now, for the lesson plan, you wanna do the lesson connect to this class, okay? Anything related to algebra, anything related to function, or anything, you know, the content area cover from 389, okay? So you would write a lesson plan for 4th grader to 8th grader, from 4th grader to 8th grader. You cannot take a 388 class using this class, no. 388 class is from kindergarten to 3rd grader, more 4th grader. So this class is more like elementary and middle school. So you want to have a lesson plan for 4th grader to 8th grader. So I prefer the content area is the things we cover this class. For instance, you can use the I think I go over for the 50 item computational test, right? So you can use the information there. Like if you want to do fraction, percentage, you still can use it at, or you want to do anything, you know, it's things we have already covered from this class. Does that make sense? Okay. And then here is a rubric. Oh, here's a rubric. Now rubric is like this, all right? So this is a pretty much like a live text. You know, you download all the lesson plan. You need to upload one to D2L, and you want to upload another one to the purpose of a TEP program, which is on live text, okay? So you need to upload 2. You know, one is from upload to D2L to turn in the homework. The other copy you need to upload to live text for the purpose of TEP requirement. All right. So do you have any question for this?
Are you going to provide us the template to write out the lesson plan, or do we have to find that on our own?
I think the template you can, you know, using the TEP, the one that, you know, I think if you have a EDUC program, right? EDUC courses, right? And then they might have a template for you like this, okay? So here is an example you can find from the D2L, okay? So you would do part 1, part 2, but you don't need to do part 3. This is will be the lesson plan, like give some idea. You want to teach the lesson, but you not actually teach. Only part 3 you actually teach, but actually you only do part 1 and part 2, okay? And make sure, I think a lot of time people, make sure you have the align with the standard, or what's the standard, you have to align, and you have align with the standard, and which is a goal, and what is your assessment. So your assessment, you have a goal, you have objectives, then you have a lesson based on objectives. Then you have assessment to assess what's the goal. Did you achieve the goal or not achieve the goal? Does that make sense? So each objectives, you have to think about what kind of lesson I'm going to teach in. Then you might have assessment for this. For instance, I'm teaching fraction division, okay? Now, fraction division, that's the goal. I want to teach you fraction division. The next, I'm a whole bunch of activity, kind of leading and guiding fraction division, right? And then do the practice, something like that, right? Then later, we have a assessment to connect with this. All right. So you don't want to just, copy and paste any assessment put in here. No, you have to match with your goal, okay? If you are teaching fraction division, you're teaching fraction multiplication, then you might have a whole bunch of activity, lessons, to teach this goal. Then you want to have your assessment to assess, does a student understand how to do the fraction multiplication or division, right? Does that make sense to you? Do you have any question for this? Do you have any question for this? I can answer you right now if you have any questions. Everybody clear with that? And I give you the example. If you not quite, here is an example. You can follow this example to, to take a look, what's the examples. And then, for instance, this one, I'll show you on the screen. This one is a lesson is talk about what? It's a talk about, I think so, talk about slope intercept form, right? We talk about slope intercept form, right? So here, here's all, the goal is like teaching slope intercept form. Then we have a lesson for this, and how to teach a slope and how to teach a y-intercept and something like that, okay? And then you might have assessment for this. Clear? Do you have any questions? Okay. If no questions, then I will move on to today's lesson, okay? And then also lesson plan, you might think about your activity is like a more, is it connect to the real life context? You want to teach a lesson is not pure math, okay? You want to teach a lesson is a school of mathematics. Get this, you want to teach children school of mathematics, not teaching them pure math. So you need to have find something like examples, okay? Fraction, for instance, okay, you want to find the examples about teaching multiplication, a fraction multiplication. And then I was thinking about maybe I will connect to cooking, right? Cooking classroom, right? And how much measure, put in there and then see how many I have it, right? So I think you might connect with a real life context, okay? And the language is the audience is for what? Is for children. It's not for adult. It's for children. Does that make sense for your lesson plan? Okay. So you can learn from the examples. Okay. And I think I'd like have you to come up with some real world example and then connect to your lesson plan. Okay. All right. So now I'm gonna move on to today's lesson. Today's lesson is a function. Okay. So I'm gonna move on to today's lesson, function. All right. Can everybody see the screen like this? Function?
Yes.
Okay. Speaking of functions, can anybody tell me, to your best knowledge, what is the functions? What is the functions? Can anybody tell me? Or something you can think about function. Anybody?
One word that comes to mind whenever I think of it is like input.
Input, yes. And in input and output. Very good, very good, very good. Yes. What else? Anybody? Function. Well, the language says functions. That means you put input and output must be functional, must be working, right? If you have an input and output is not working, then it's not function. Yeah. So today we're gonna learn this. We're gonna learn sometimes we have input and then we don't have output, and then there's no function. So therefore, we don't say function. If we have an input and then we have an output, all right, and then works perfectly, that means a function, okay? Now here's a definition for function. What is the definition here? Here's a definition, say a function is a relation, and in which each element of a domain, okay, we have a domain, and tell exactly what element of range, right? Oh, we have input and output. Input is the terminology called domain x. Range is y, right? So equation that a function can be written in the form, the functional notation. We say f of x, read f of x. In a function, x is an element of the domain, and then f of x is the corresponding element in the range. Usually, f of x actually is y, okay? Now we have x, we have y. That's input, that's output, all right? Can anybody give me an example, real world context for this? Can anybody think about any example? Maybe I can start with this, all right? Did I give you the example of a gas station? Example? If I fill in, what's the gas, a gallon, how many dollars right now? Does anybody just fill in the gas recently?
It's like something.
$5? Almost 5?
Like 375.
375, okay. Yes, 370. I think that in Illinois is pretty much, $3 and $4, no more than 5, right? If a 5, that means something. If this is a happen, there's a wars, in the Middle East. So therefore there is a gas price going up. So look, a per gallon like $3.67. Then outputs Y is how many dollars you need to pay to fill in the full tank of the gas. Does that make sense to think about it? Input and output. So your lesson plan, I like have you to think about, this is a mathematics, right? But I like have you to think about what's the real world you can find and tell the children, about the story. What's the X and Y relation, okay? Now, again, here's a relation. Here shows express relation showing the mapping below sets, then state the domain range inverse relation. So here, set of the pair is a 3 and 2, 4 and 3, 8 and 6. Now, what's the domain? This is called a domain. 3, 4, 8 is a domain. What's the range? Y, that's a range, okay? To write the inverse, that means from here, make into here, 2, 3, and then here, 4, 3, and then here's a 3, 4, and then it is a 6, 8, okay? So this is a kind of relation between X and Y, all right? Relation, okay? Now, can you take a minute to number 5? Can you take a minute to number 5? Find a pair, find a domain, find a range. Take a minute, do the problem, okay? Tell me when you were done. Tell me when you were done. Are we done? Or you need a minute? Okay, I want to find a pair. So first of all, I want a pair 20 and 15. The second one is 22 and 18. Then the third one, 25, 19, and then 31 and 20, okay? Now, what's the domain? Domain actually is 20, 22, 25, 31. Now, range actually is a 15, 18, 19, and 20, okay? Then inverse, INV. Inverse, I would say 15, 20, and then next 18, 22, next 19, 25, next 20 and 31, okay? And I want to leave the number 5, number 6, and number 7, okay? Because we will come back this. And I will have you to determine this is a function or not function, okay? Now, let's take a look for next one. Domain and range. Can anybody tell me this is a function or not function? Yes or no? If this is a function or not function? Yes or no? Function or not function? I can hear you.
No.
Somebody say no. Yes or no?
No.
No? Okay. The answer is yes. Why? Because each domain can find a range. 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 So yes, this is a function. Okay. Let me give you another example. And you want to tell me yes or no, okay? Yes or no? Function, yes or no?
No.
Somebody say no. Does anybody say yes?
Yes.
Yes, okay. So we have a yes and we have a no. So the answer is yes. Why? Because each domain find a range. Each domain find a range. Even though it's the same number, it's still okay, okay? Even though it's the same number. Each domain find a range, yes. Each domain find a range is yes, okay? So this, yes, all right? Next one. Yes or no? Yes or no?
No.
No? Does anybody say yes? The answer is no. Very good. Why? Each domain find a range. 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 Now each domain find two range. Oh no. So therefore, no. You cannot find two range. You only can find one range. Does that make sense? Like this, you find one range. You find one range. Okay, yes. Next one. Yes or no?
No.
Function or not function? All right, somebody say no. Does anyone say yes? The answer is no. Why? Each domain find a range. 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 Now, 16, there is no home. Therefore, this is no. Does that make sense to you? Okay. So now, okay, make sure each domain find a range, okay? But you cannot have each domain have two range, only one range, okay? But if it's the same number, it's okay, okay? So I'm gonna go back to here. Number 6, what do you think? Function or not function? Number 6, function or not function?
It's a function.
Yes.
Yeah, you gave good eye, very good. How about number 5, function or not function?
Function.
Function, right? Does that make sense? You can find a function, not function, right? Now, what about 7, function or not function?
Function.
Function. Each domain have a range. Yes, very good, very good. Yes. So based on this, we can determine function or not function, okay? Now, here, another way we can determine called a vertical line test. Does everyone learn vertical line test when you're in middle school? Yes or no? Do you still remember the vertical line test?
Yeah.
Yeah. Now, here is why the vertical line test is important, because that helps us to find the function is not function, okay? If each vertical line test pass through no more than 1 point, no more than 1 point of the gravel relation, then the relation is a function, okay? So let me give you an example. Function or not function? This one, this graph, function or not function?
Function.
Yeah, so I want to use the vertical line test. So if I use the vertical line test, then what happened? I meet how many points? Just one there, vertical line test. There. Does that make sense? Just only one, right? How about another example? So this one is okay. So I'm gonna do another example. How about this one? Function or not function? Does it pass the vertical line test?
Yes.
Yes.
Oh, if I draw a line like this, meet 1 point, right? Yes. So this one is a function. So if a graph like this is a function, okay? Now what about graph is like this? Function or not function?
Not function.
Not function. Because the vertical line does not pass that this is maybe infinity, right? So what's the between why this one is why this is not no, this is a yes. Why this is a function, and then why this is a function, why this is a not function? Why?
Because if you draw a vertical line on the left one, then it's going to touch all y coordinates
Yeah,
and only one x.
yeah, the only one. So look, when we talk about last time, we talked about slope, intercept form. We have a slope, right? Now slope here is a 0. Is that right? This one is 0. So that's why this is a function. But what about this one? The slope is what? Undefined, right? Divided by 0. Now when you divide it by 0, you will have this. Does that make sense?
Yeah.
We talk about slope, right? So slope, this is a 0. When we calculate slope, 0 is this. Let me give you another example. All right. Does it pass the vertical line test? Yes or no? How about this one? This function or not function?
Yes, it's a function.
Yes, because we put on the vertical line test, we only meet 1 point. No matter what you do, you will just, you would meet 1 point. So yes, this is a pass the vertical line test is a yes, this is a function. Now, what about this? Function or not function?
No.
No, because you meet 2 point, right? Now, meet 2 point, then what is it like this? That's why it's no. Does that make sense?
Yeah.
One domain cannot have a 2 range, okay? One domain cannot have 2 range. One X cannot have 2 Y results, okay? Now, no, you have a input and then you output only 1. Remember, your output is only 1, okay? about this? I want to make a circle. Function or not function?
No.
No, because it does not pass because you might meet the 2 point there. Okay. So I want to move on to next lesson. Okay, not lesson, next problem. Now, based on the vertical line test, based on the information I give you, can you find is a 1, 2, 1, 3 a function? Is a 1, 4, 3, 2, 5, 4 a function? Can you take a minute, find it out? The first one is a function or not function?
The first one, no, and the second one, yes.
The first one is a no because one output cannot have one input cannot have two output, right? Yes, so no. This is a no. The second one, yes or no? Input,
Yes.
input, and only one output. No matter they have the same answer, you still okay, right? And then this is a look like which one is okay. You know, okay, you have one domain and they have the same answer, still okay, right? Yeah. Is that make sense to you to determine function or not function?
Yeah.
Okay. Or if you're not sure, you can you can graph and you can draw the line and using the vertical line test to determine. Either way, right? Yeah. So I think so right now you have more clear mind for function or not function, okay? You have one input and one output, all right? Okay, very good. The next, for the school mathematics, teaching function, we can use the function machine, right? I think so you have read the article about function machine, right? And function machine is like you have inputs and you have a rule and you have outputs, okay? Now here, let's say inputs, this is a rule, y equal to x plus 3. So input is 4, right? So I put down 4 there. 2 times 4 plus 3. And sometimes we can say f of x. F of x is the same as a y, okay? So we have 2 times 4, 8 plus 3. So output is 11. So y is equal 11. And f of x is 11. Does that make sense to you for function machine?
Yeah.
So in this function machine, you might have one output and then you might have one input and you have one output, right? Okay, now let's do. So look, here this example can give you the idea. This is a function machine, and that's the rule, right? And that's the rule. And then FR1, can you plug in FR1 and find out what is the FR1?
2.
Yes. So I'm gonna put on the machine like this. So what's the rule? Rule is 3x minus 1. If I have a 1 put in there, 3 times 1 minus 1, which is equal to. You are right, it's 2. Function machine, right? So what's the benefit we teaching children using function machine? Can you tell me what's the benefit of using function machine? Instead of you have just plug in, you can do plug in and you can do function machine. This is a traditional approach. This is a hands-on activity approach. What's the benefit of using function machine?
It gives students a visual.
Visual, right? And then we can also have some fun activity for children to do that, right? Does that make sense in terms of teaching? So I think that your lesson plan, I like have you to do is not a traditional approach. I like have you to do something hands-on activity like this. You might have a function machine and make something fun. You're not just plug in, it's just plug in. That means you are teaching pure math. We are not teaching pure math. We are teaching school mathematics, okay? Now here, another function machine. Now here is a 2x. G over x is 2x, okay? Now, what is G3? What's a G3 there?
6.
6. So the input is a 3 and the output is a 6. Is that right? Okay. Now, can we have a 2 function machine connect to each other? Just do it. 2 function machine connect to each other. And this is a 3x minus 1. And this is 2x. Can anybody tell me if I have an input there? Well, I connect to function machine, okay? Function machine f of x, the other function machine g of x. If I have put on 1, what happened? What's the output?
Do you want the end output or just the output of the first one?
I think that I want the output here.
So 4.
Okay, let's try it. Okay, so you have a 3 times 1 minus 1 is 2, right? Yes, very good. So here is 2, right? And 2 times 2, did you get a 4? Very good. The output is a 4. Can we try another one? How about 3?
$16.
All right. So you put in there is 3 times 3 minus 1. 3 times 3 is a 9. 9 minus 1 is 8. 8 times 2 is a 16. Very good. Yes. So this function machine, in mathematics, we will have this. This is a mathematical writing. Connect to each other. So look, f of 3, which is 8. Then g of 8 to x, which is 16. Does that make sense to you? This is a mathematical writing. This is a connect to 2 function machine. Have you ever learned this before? Have you ever learned this before? And what does this mean? That means this. That means this. If you do hands-on activity, the children will get to understand what's going on here. Does that make sense to you for connect to 2 function machine? Yes or no?
Yeah.
Okay. Can we try another one? I'm gonna try this one. Okay. So I'm gonna do 2x for here. I'm gonna do 3x minus 1. Okay, if I input, what's the output? Tell me what's the output.
Five.
Very good. So 2x, actually 2 times 1 is equal to, so here's a 2. Now 3 times 2 is 6, 6 minus 1 is 5, very good. So in mathematical writing, how we write it is, we have, because this is this, so we have a g of 1 and f of g of 1. So actually in mathematical writing actually is this, f of g1 actually is 2, so 2 f of 2 is equal 5. Does that make sense to you? Can you see the function machine and the mathematical writing? The meaning of this actually is connect to different machine, okay? All right, so now, yeah, if we do, let's connect to 2 function machine. Yes, we talk about this. Okay, tell me which one is a function. Take a minute. Number 1, yes or no? Number
Yes.
Gorgeous, so that really it solidifies that even
1.
more.
Does
But
each x
when I think about last
find,
night, your
the home, right? Yes, so this
Yeah.
I had the mother and son kind of deal, and you come out here and you
number 2, yes or no?
No.
It's really cool.
Why?
Because 2 has 2 outputs.
Yeah, to have 2 outputs. So this one is no. Very good. You have good eye. Number 3, yes or no?
Yes.
Number 4, yes or no?
Yes.
Yes. Even though they have same answer, still okay. If you look at the graph, still okay. So this is a function, okay? All right. So now, take a minute, do the problem, okay? Find 11, 12, 13, and 14.
Do you want us to give you the answers or just let you know when we're done?
I think I want to go over all together. So finish the 1 through 14, okay?
Okay.
Finish 11 to 14. Okay, are we done?
Yes.
Okay. Number 11. Did you get negative 21? Yes or no?
Yes.
Down the 7 there, the function machine output is negative 21. Now G machine, okay, I will say G machine. You put a 7 there, you got a 2 there, right? The next one is a G machine. You put on a -8 there, you get a -13. And then 14, it's a F machine. So you put on the -1 there, so you got a 3. You got all right? All right,
Yeah.
very good. Next, application problem. First of all, read this graph, function or not function. This is a function or not function?
A function.
Yes, function, because does it pass the vertical line test, yes or no? It passed the vertical line test, right?
Yeah.
Okay, so now read this. Carol Lee made a trip to the store one afternoon. Her trip is shown below, and where her distance from home is a graph as a function of all past noon, okay? Refer to the graph, answer this question above the trip. Okay, now here, what time did she leave home? What time did she leave home? Can anybody tell me what time did she leave home?
Like 12:45.
12:45. Very good. Yes. 12:45. Very good. Next. When did she realize she forgot her checkbook? She forgot and then she had to return to get it, right? When? When did she realize she forgot her checkbook?
Like 1:15.
1:15. No, I would think so. I would say 1. Okay. And next, what did she do what did she do about the forgotten checkbook? Actually, she returned home, right? Yes. Next one. When did Carly park her car at the store?
Is it at like 1:30?
Yeah, 1:30 right here, right? Good. How long did she shop? How long did she shop? How long did she shop? From here to there.
For an hour?
An hour, yes, very good. How far was the store? How far was the store? So here's the miles. How far? It's about 10 miles, right? 10 miles. Okay. Pretty much this problem is kind of helping children to understand the graph, how to read the graph, okay? Now here is another problem. Last problem for today, okay? You want to take a minute, figure it out. Okay, first of all, can you tell me all the graph or function or not function? and kind of match, okay? Temperature of a pan water placed on a hot burner, which one? Height of a flag being run up the flagpole, which one? Height of a weight hung from slinky. And length of the shadow of a flagpole throughout a sunny day in Dallas. Okay, it looks like you're done, right? Temperature, okay, let's go over this. Temperature of a pan of water placed on a hot burner. What do you think? This one, or this one, or this one? Which one? 1, 2, 3, 4. Which one? Temperature of pan of water placed on hot burner. Which one?
Bottom left.
Bottom left. Yes. So yes. Put on A here. Temperature of a pan of water placed on a hot burner. Yes, this one. Next, height of a flag being run up the flagpole. Which one? Top or bottom? Height of a flag being run up a flagpole. Do you think this one, the first one, the second one, or 4? What do you think?
The second one.
The second one, correct. Put on B there. So now we have 2 more. Height of a weight hung from slinky. I don't think the slinky will be the last one. Do you think the slinky will be the last one? No. Slinky will be first one. What do you think?
Yeah, I think the first one.
Yeah, first one, very good. And this one must be the last one. The length of a shadow of a flagpole throughout a sunny day in Dallas. All right, that this one must be. So this is a kind of a activity can connect with science. All right, science class, right? And then in math and science, you know, we have activity can join together to learn, and then we can read-find the graph. Okay. All right. Do you have any questions for this problem? Okay. I think so. We are here for today. Do you have any questions? If you have any questions for your lesson plan, you know, you can let me know. Okay, now I'm gonna close this one.
The grades for the lesson plan just need to be 4 through 8, correct?
Yeah, 4 through 8, yes. Yes, because 380A is focused on my kindergarten to 3rd grader, right? So I think that this one, when you do the teacher education program for the portfolio, you might have 2 lesson plan in mathematics. One is 380A, one is 389. So you might have one is a higher lower level grade, the other is a higher grade. So I think so we will focus on 4th grader to 8th grader, okay? Okay, do you have any questions? All right, if no questions, we are here for today. Thank you.
Thank you.